Good morning, class. Today we are going to be talking about the PLC programming. I need to give you an introduction to the PLC system. The PLC system includes two parts, the software and the hardware, the PLC, the hardware. This is click software that we are going to be using, and this is the click hardware. The hardware includes the PLC CPU. This device by itself is a computer. As a computer, it has its own central processing unit or CPU inside. Also, it has two types of memory, the random access memory and read-only memory, both of them. And it has input devices to capture the information from the external world, and we have output devices that deliver the information, the result of the CPU to the external world to control electrical devices. The main reason of a PLC is to control electrical devices in an automatic way. The CPU is connected by a serial communication port. In this case, it's a serial port, COM1 or COM2 communication port, using a USB interface to a computer system. And the computer has the software that we have here on the screen. And this block, terminal block, is divided in two sections. On the upper section, it has the input. It's input devices that collect information from the external world, and they are identified by letter X. And at the bottom, we have the output devices that are identified by letter Y. And let's start talking about this program, okay? So right here, today we are going to be testing several scenarios, okay? So we are going to be using some conditions, okay? The typical condition, unconditioned, or condition, exclusive, or, and also non-retentive latch, okay? Typical use on electrical motor control. And right here on the software has two sections. This is the condition or conditional section in which I create my condition, and this section is the output. And this simulates a ladder diagram, which means that on the left side I have the power, on the right side I have the neutral, if I am dealing with 120 volts. And I will use this example because normally the control system, electrical automatic control system, work at low voltage level, maximum 120. However, it could be system that use 208, phase 1 over here, phase 2 over here. But I will be using the low voltage system that includes L1 on the left side and the neutral on the other side. And as I told you, this is the conditional area in which I will create my conditions, and this is the output area. And the software includes at the top, we have the instruction, the PLC, and the monitor. We are going to be using some of these options in the menu. Okay, so we are going to create, first of all, a non-retentive latch. Okay, let's do this. So as I told you, if you look at the screen, so I will create, I go to instruction, okay, and then right here I have the normally open contact, and I will select, I click on this menu, I will select X001 as one of my input. And if you look at this is in the traditional ladder diagram, this represents a normally open contact. Also, it could be representing here a switch, okay? So when it's open, it's false. When it's closed, it's true. But now we have a normally open contact that it could be capturing at the hardware level the input of any switch. A switch could be a thermostat, it could be a motion sensor, it could be a limit switch, a pressure switch, or a switch detecting airflow. There are many forms of switches, okay? But this contact is representing my switch, okay? And right here, so on X, I have to connect that switch that will be providing the input to this contact. Okay. So then I will have a second let me replace this for some reason. Let me erase. If you want to erase any of these, you right click on it and click on cut. So I will use a normally open. I will select X2. And then on the second one, I will select X1. Okay, these are my conditions. And then on the output section, keep in mind, I was telling you that this is my condition area, which means that when I have this, it's an AND condition. It means that both conditions should be met. So this input at the hardware level is capturing, is collecting the information from one switch, and this one is collecting the information from the second switch. This could be a thermostat, this could be a motion sensor. So both conditions should be met in order to have an output. So I will select the output. If you look at the screen, on the second column from the left, on instruction, the second column from the left, I have the output. Also on the right side, right here, I have the output as well. And the output, as I told you, click on this menu, the 3-dot menu, is giving you the access to this menu. So the output are represented by letter Y. So I will use Y001. And I need to tell the software when or where my program is ending. So I need to include an instruction to the end. Right here, I have the end condition. So in this case, both conditions should be met. Both conditions should be met. This plus this switch should be closed, and this switch should be closed. This input device at the hardware level should be true, and this one should be true in order to have an output, okay? If one of them is open or false, we won't have an output. For example, if I have a thermostat, okay, connected in a series with a motion sensor, and I preset my ambient temperature at 78 degrees Fahrenheit, and the motion sensor, both of them should be closed in order to have an output. In other words, the ambient temperature, if I am using the cooling system, the ambient temperature should be higher than 78, and there should be people in the room. So my motion sensor closed, my thermostat will be closed, both of them are closed, then I will have the output. What do I do with the output? It could be providing the power at the hardware level. Y001 could be connected to the contactor relay, okay, the contactor coil, and energizing the contactor that will be starting up an electrical motor. Okay, but in this case, we are going to test it. We are going to test it using this latch. In the way that it is, both of them, if I am using push button here on this hardware, I need to hold both of them, okay, to have an output. I need to hold this because this is a push button, X1, right here. X1 is a push button. So if I press this down, in order to have an output in this, using these conditions, I have to hold this down. Immediately I release, I won't have an output. So if I want to latch this condition, when both of them are through, or when I push this down and then I release it and I want to hold my output, I use a branch here, which is what am I going to do? Okay. In this case, I will create, I go to the edit menu, line, okay, and look, hold, click on the arrow in the direction in which you want to drop the line. So hit escape, and now we are going to have another instruction. I click on instruction, I go to the normal open. So in this case, I will use the latch Y001. Y001 is normally open, but when I have an output, this output will be closing this and hold it, okay? So let's test it. Before I test it, I need to write the program, okay? So I go to PLC, look at the menu. Then after I click on PLC, I click write the data into the, write the project into the PLC. And right here, I will select COM4, don't use COM1, okay, and then get connected. And at the bottom, it's telling you if you have any diagram. So I will save this with new project, 92, I save it. And then it's asking me to write this project file into PLC, which is the hardware. And it's asking me to turn the PLC off, no off in the stop mode, so the software could be able to write into the hardware. So I say yes. The answer yes. Now I need to go back to run. The hardware should be on run mode to be able to test this. And you will see, you see the aqua color here, okay? And look, I need to tell you this. This is my red push button on the PLC trainer, okay? And like when we use a push button station to start an electrical motor, the red one is closed or stop, or is closed, so normally closed, and the green one is normally open. Okay, so even though you see it's using what is known as a negative logic. Okay, you saw it when you put it in on the conditional area as a normally open, but in reality is using the negative logic is closed. Okay, so what we are going to do is test it. So because this is closed and it's an unconditioned, if I close and hold X001, look at the screen, I have an output. and you see this, okay? So, and its latch is whole because I have this Y001 normally open contact depending of this output, okay? This is a typical behavior of the push button extension, in which you have the red one is start, the green one, stop, and the green one is start, and then you have the contactor, the contactor that will be energizing and starting your electrical motor has an auxiliary contact, an extra contact that is normally open, which is this one. When the contactor coil is energized, this contact is closed and holding the output. If I want to stop it, what I need to do is press the stop push button here and look at the screen. It's closed, it's true, but I don't have any output. Okay, so now, if I want to save this, I need to go to monitor, status monitor, look, is de-energized, and now I click on file, close the project. Okay. And this is the first lab, introduction to the PLC, the first lab. And keep in mind, PLC system include the software part and the hardware, okay? And this system, PLC systems, in general, PLC systems are used to control electrical devices, either lighting system or electrical motor or doors, in an automatic way. But you have to have some condition, and the software will be understanding, collecting the information from the condition area and transfer those to the output. Who is in charge to translate your program? The PLC CPU. The PLC CPU get the input, hold the input in the input table inside of the memory, translate the program, make a decision based on the program that you has been written, and send the result to the output devices, okay? So this is what I have for the first lab. Thank you very much, guys.